Number 18 is going to be another two-parter. So we're going to start with the ideal gas law, and we're going to end up solving for the number of moles. We're going to solve for the N value. Our second step is going to be a little bit different in number 17, where we were simply solving for that N value, that number of moles. We're still going to solve for moles here, but we're going to do something different with that number. We're actually going to put it underneath a gram value, which you'll notice that number 18 is giving us, right? So here are three values that we're going to plug into the ideal gas law to solve for N, right? And then we'll have a number of moles, and then at the end we'll put this value over the moles for a fraction, and that will be molar mass, because remember, molar mass is grams over moles, and so we'll be taking our grams and putting it over the moles, which is what we'll be solving the ideal gas law for. Just remember, looking through these units, make sure that your units are straight so that we can use the version of the ideal gas constant that is the most convenient for us, right? That's the degrees Celsius. I do not want to have degrees Celsius in my gas law calculations, so I want kelvins. So I'm going to take that degrees Celsius and add 273 to it. That's 310. 310 K. I'm going to do the same thing with this negative 23 degrees Celsius. Negative 23 plus 273 ends up being 250 K. And I see that this value for volume here is yours. And so I want to get rid of the milliliters. I just want to be in liters. So how do I do that? Well, this number is actually, notice that it's times 10 to the second. In terms of its true value, is actually right there. I want regular liters, and so I'm going to move the decimal to the left 3 times. 1, 2, 3 to get me liters. Now, with all my units in liters, atmospheres, and kelvins, right, I can use my ideal gas constant of 0.0821 liters atmospheres per mole Kelvin. So let's start setting these up. Solving for N again, so I'll just use that same version of the ideal law that I have used on numbers 16 and 17. Again, you don't have to memorize this. You can always just rearrange the ideal gas law to solve for whatever quantity